Now we will understand the code for the binary search problem. So we are calling the search function with these values in an array, and we want to search for 70. And now we have like a wrapper function search, which will be used externally, but internally we have the search implementation function. This IMPL is just short for implementation. So this is a common strategy that we'll use when solving recursive problems. We'll understand why soon. Uh, Here we are just passing the array and the value, and we are also passing the starting value, because in the first iteration the starting value of the array is 0, and later it will change. So we will see that in action. Now let's debug this code. Alright, we are in line 105 here, and let's go inside this function. Okay, now the array is our original array, and we are searching for 70. Now we can see that the length of the array is greater than 0, so we are not yet in the base case. Now we'll compare our value with the middle value. The middle index is 4, so, and array of middle is 40, right? So our value does not match 40. That's why we need to now solve the subproblem. First we need to identify the subproblem. To do that, we'll compare the value with the middle value, and we can see that the value is greater than the middle value. 70 is greater than 40, and that's why the next array is the right hand side portion of the array. So the next array is all the values to the right of 40, which is 50, 60 and 70. And we also have a new starting position now. Now that we have moved our array to the right a little bit, the new starting position is next start, and its value is 5. And we will use this to keep track of where we are, so that when we eventually do find the target value, then we can use this to return the index. Okay, I will share the code with you, and you can see how it works in more detail. All right, so now we have identified the subproblem 50, 60, 70, and we want to find 70 in this array. So let's go inside. Now once again we have recursively solving the problem, and we'll repeat the process. In this case, the middle value is the middle index is 1, uh, and what is array of middle? Array of middle is 60, and 60 does not match 70, so we need to go deeper again, and 70 is greater than 60, so once again you have to go right. Okay, now the next array will be just the value 70, and the next starting value will be 7. All right, and we need to solve the subproblem, where the new subproblem is the array 70, and we are also searching for the value 70. All right. Okay, in this case, once again, the length of the array is greater than 0, so we don't go inside the base case. Now the middle value, the middle index is 0, and does it match our value? Yes, it does match the value. So now we can return the index of the matching value, which is start plus middle. In this case, start is 7 and middle is 0, so we return 7. Okay, so we'll go outside, and now we, because we went outside that iteration, we are into the previous iteration, and we are also solved the previous subproblem, and this process continues. We are now back to the main problem, and we will return the final result. So that's how binary search works. If you want to quickly see how it works, we can just run this function without any breakpoints, and you can see the same thing in action. So initially we had this array, and the starting index was 0, and then we went right, and the starting index was 5, and we went right again. Then we solved the smaller subproblem, then we solved the next level of subproblem, and finally we solved the original problem. So in this case, we went right in the first iteration, we went right in the second iteration, and finally we solved the problem. So depending on the value that you are searching for, you will take different paths to reach the destination. Now let's try a maybe like let's try to solve a bigger problem. Maybe let's add some values. Now we have like 12 values, and let's search for let's say 30. Okay, so in this case 30 is less than the middle value, so we went left, and then uh, we are solving for this subproblem, and 30 matched the middle value. We exited very quickly. So you can see that this algorithm is much faster than linear search, right? We are quickly zooming in on the target value, because at the end of each iteration we are eliminating half the values, and if we do find the value quickly, then we are exiting very quickly. Okay, so this was like a quick this was a quick case. Now let's search for 10, or maybe let's search for 20. What happened? All right, so in this case you can see that there are like more iterations. So once again we'll go left in the first iteration, uh, and now we have this new subproblem, and 20 is less than 30, so we are going left again, and we have this new array now, but now we are going right. So now the path we have taken is left, left, and then right, and finally we solved uh, the problem here, and then we are like bottoming out, and we are going up and up until we finally return the result of the final problem. So this is how binary search works, and I know that intuitively you can see that it is kind of fast, right? So let's visualize that path that you have been taking. So let's take this example. We have 1 2 3 4 as our original array, and if you go left we get this new array 1 2. If you go right we get 3 4, and once again if you go left from this array we get 1, and finally we have all these values here. So you can see that for every value, every target value, we have a different path. So to reach 1 we need to go left and then left. To reach 2 you have to take the path left right, and for 3 right left, and for 4 right right again. So depending on the value, the path that you take is different, and each value has a unique path, and binary search quickly goes to the desired destination by taking the shortest path. So you can think of binary search as in this way as well visually. Okay, finally, why is it more efficient? Let's learn just a little bit of the theory. In linear search, if the size of the array is, let's say, like 128, which is 2 power 7. So if our length of the array is 128, then we need up to 128 iterations to search for our target value. On the other hand, if you're using binary search, how many iterations will it take? I'll pause the video, think about it. Okay, so if you have 128 values, at the end of the first iteration, we'll have only 64 values. At the end of the second iteration, 32, and then 16, and then 8, then 4, then 2. Finally, we have 1. So we need up to 1, 2, 3, 4, 5, 6, 7, 7 iterations to solve our problem. So we need we need 7 iterations, which is equal to log of 128 to base 2. So we need only log n iterations to search for our value. So this is much faster than n. So you can see that 7 is much smaller than 128, and this effect is much more palpable if we have bigger values. So for example, if you have like 1024 values, which is equal to 2 power 10, then for linear search we need 1024 iterations. On the other hand, we need only 10 iterations if you're using binary search. And that's why this technique is very commonly used throughout software engineering. So that completes binary search. The next video, we'll learn how recursion can be applied to another problem.